All right, so I'm not sure how much got cut off. The problem with using, you see these advertisements on TV and they say, this entire video, this entire commercial was filmed with an iPhone. Well, I'm using an iPhone. But the problem with using an iPhone to film a commercial or a lecture is it's a telephone. So I got a call right in the middle of when I was talking about human papillomavirus, but we were right at the end of our discussion of cancer. So I'm just going to kind of pick it up and say, just make my final point that human papillomavirus is a major cause of cervical cancer. And so, and it can be prevented by immunization. So anyway, so that's the end of cancers. I'm not sure how much of my previous talk we missed. All right, so we're going to talk just a teeny bit about the origin of cells. So I was talking about lysosomes, and I'd said that we had talked about how you have to develop fingers and things like that from the limb bud. But what about, we have cells, and if we think about that fertilized egg, that fertilized egg is a completely unspecialized cell. And we hear about these unspecialized cells, and for a while, there was all this pushback on research in stem cells. Now, there's nothing wrong with stem cells, but the problem was that politicians and society decided that human nature is bad. And so if you allow scientists to do research on stem cells, they're going to do something unscrupulous to get them. And that would be like, having early abortions and things like that, because those early cells haven't differentiated yet. And so a cell, so if you think about the developing embryo, it starts out as a single cell. And that single cell becomes everything, from the bones inside of me to the blood inside of me to the photoreceptors in my eye, my teeth, everything came from that stem cell. And so when we talk about a stem cell that is completely undifferentiated, it is totipotent. Potent is we're making reference to what it can become. Toti meaning everything. A totipotent stem cell can become anything, right? So we have this stemness, this totipotent stem cell. Now, as that totipotent stem cell starts dividing, you end up with a hollow ball of cells. And so I'm making reference to embryology. You don't have to know this, but you reach a point to where you have this hollow ball of cells, and there's this process called gastrulation, and you don't have to know that. But what that means is at that point, you have various parts of this ball of cells that have already differentiated a little bit. It's only a ball of cells, so they've only differentiated a little bit. Some of them will become skin and nervous tissue. Some of them will become muscle tissue, and then some of it will become your gut. And so at that point, these are what we would refer to as pluripotent stem cells. That means they can become a lot of stuff, but not anything, not just everything. So as these cells are differentiating, they become more and more specialized. And like in you and I, throughout life, in our bone marrow, we have stem cells that can only become different kinds of blood cells. So these would be cells that are partially specialized, but they could become a number of different kinds of different blood cells. So they're pluripotent still. And then in other cases, you have stem cells that have become so specialized, like in your skin, all they can, you have an injury, this unipotent stem cell can only become skin. It's the stem cell that isn't skin, but it can become skin. It can divide to produce skin. So we have this process of becoming more and more specialized, which involves stem cells. And then you can think of the cells that skin came from. It is a stem cell, but you can think of it as a progenitor cell, something that gives rise to it. So a progenitor cell is a cell that is committed to become one or more different kinds of mature cells. And I think the last slide I have here is one that basically is showing this pathway, with the egg, the fertilized egg, and then becoming more and more specialized different kinds of cells. All right, so we've got 20 slides here. Maybe I'll hold off on the connective tissue, the neural tissue, the tissue part of things. So I'm going to just stop right here for now. All right, guys, have a good day. I'll see some of you on Wednesday, Thursday, and Friday. There's a portion of you that I won't see, so I'm so sorry. See ya.